Okay, class, welcome to another math lesson. Still in Module 2 of Eureka Math. Lesson 6 this time. Lesson 6 is going to be about rotations again, but we're going to look at a very specific rotation today. Rotations of 180 degrees. So you will need pages 55 through 68 of your book, plus your transparency tools in order to do your rotations. And there's going to be a lot of exploration activities today, so make sure you're following close attention, being precise in your decisions, being exact in what you do, following along carefully, watching what I do so that you can do it yourself later. Because we're talking about rotations and we're going to explore some properties of 180-degree rotations. But let's talk about the road so far. So far in Module 2, we have talked about 3 rigid motions. 3 types of rigid motions. And remember, rigid motions are congruent motions where the size and shape do not change. The first one was called a slide. When we slide, the mathematical term for it is we translate. Slide and translate are the same thing. The rule for a translation is called a vector. So you should remember how to do those, where a vector shows you what direction and how far to slide the translation. Rigid motion number 2, we started calling a flip, but now we know better. We know that when we flip, we really reflect. And the rule we use for a reflection is called the line of reflection. Kind of like the mirror. What line do we flip over? And the third type of rigid motion was a spin, which we know better now. When we spin, we rotate. And for the rules, when we rotate, we need 2 things. We need a point to rotate around, a point to spin around, and a number of degrees so we know how far to spin. So those are the 3 types of rigid motions and the rules we use to create them. Now, that's what we've been studying. Let's talk about what we're going to do today. Today, our focus is on a specific rotation, a 180-degree rotation. So we talked about rotations the other day in lesson 5. Now we're going to focus on one specific kind of rotation of only 180 degrees. And we're going to do some explorations, and we're going to learn about 2 properties of 180-degree rotations. Now, I'm not going to write them down now. There will be 2 of them, 1 and 2. But let's explore a little bit. Let's get our transparencies out. Let's start rotating and see if we can discover what those properties are through some work. So go to page 55 of your math book, and you'll see example 1. It says, the picture below shows what happens when there is a rotation of 180 degrees around center O. So this is just a demonstration. It shows you. The original figure was this that I'm drawing in red. And then the center of rotation was O right there. And so what they did is they did a 180-degree rotation. We can check it ourselves with our own transparency. Label O, the center. Label the original angle, which is POQ right here. And then we rotate 180 degrees. Now you might be saying, Mr. Baylor, how do we rotate exactly 180 degrees? Well, let me show you what I do. The first thing you need to know is that 180 degrees is a straight line. So what I always do is I can take a ruler and I can remember what we did yesterday or in our last lesson. This on this side is 0 degrees. 180 degrees is over here. Remember, we talked about that and we said that this going straight up and down was 90 degrees and this is 270 degrees. So that I usually label something like that on my diagram when I want to rotate. Now what I do is I take my transparency like that and I take another dry erase and I label the 0 degrees. Now I want to rotate, so now I have what I'm rotating, POQ, and I have 0 degrees labeled. Now I'm going to start rotating. And I'm going to start it. I start the arrow at 0 degrees. I spin around. I rotate around. That is a 90-degree rotation because my arrow points at 90. So I keep going. And I stop when my arrow points at 180. That's how I do a 180-degree rotation. I mark 0. I mark 180. I start with my arrow at 0. And I rotate until my arrow points at 180. Super useful if you do it that way. And if you look, I made P prime, O, Q prime. And you can see that if we do this, angle M equals angle N. The angle here and the angle here are equal because it was just made by a rotation. So that's a little demonstration, a little bit of example about how to rotate 180 degrees. If you want to rewatch that, go back in the video, watch it again, just so that you know how to do it yourself. But let's look at example 2. The picture shows what happens when there's a rotation of 180 degrees around center O. So this time, the original is right here, point P. Segment OP is the original. Segment OP is the original. And again, we're going to rotate 180 degrees. Now, the great part about this is it's on a graph. So we can find the different degree measurements easier. But you remember that this way is 0 degrees. If we turn this graph into a big circle, here is 0 degrees straight to the right. Straight up is 90 degrees. Straight left is 180 degrees, and straight down is 270 degrees. All the way back, follow the circle all the way around. I'll even draw a circle here so you can kind of see what I'm talking about. 0 degrees is also 360 degrees. So we can use those degree measurements to rotate by 180. So watch what I do here. First thing I'm going to do is I'm going to label my origin because it's always good to know where we start. There's my origin. That's the point I'm spinning around. I draw what I am rotating. In this case, I'm rotating the segment OP. So I trace OP. And then, because I want to be precise in my degrees, I point an arrow at 0 degrees. So right now, it's at 0 degrees, but it says 180. So I start rotating, keep rotating. That's a 90-degree rotation because the arrow points to 90. So I'm not done yet because I need 180. I keep going. And there is a 180-degree rotation. Because now my arrow that started at 0 is pointing to 180. So that is where the image of the line is. So that is O and P, OP prime now. And they did that for us. See, you can see this is OP prime after the 180-degree rotation. So that was a couple examples about how to rotate 180 degrees using your transparency. Let's try some exercises now to see if we can figure out those properties. That was a little bit of practice about how to rotate with degrees. Let's practice some more. So number one is saying, on the page 56, is saying, using your transparency, rotate the plane 180 degrees about the origin. Let this rotation be rotation 0. What are the coordinates of 2, -4? So this is what we are rotating. This point down here, 2, -4. And we're rotating it about the origin. Now, about the origin means that is our center point. That is what we are spinning around. And the origin, remember, is 0, 0. Origin is a vocabulary word for right here where the x-axis and the y-axis intersect. This is the origin, point 0, 0. So what we need to do is we need to take this point and rotate it around the origin 180 degrees. So let's do that using our transparency. Now, again, I'm going to say, okay, just to help, I'm going to label where my degrees are. I know this is 0 degrees, 90 degrees, 180 degrees, 270 degrees. So let's get the transparency on top. Let's put our center point that we're spinning around. Let's put the object, the figure that we are rotating, which is 2, -4. And the third thing we need to put is our arrow pointing to 0 so that we know when to stop the rotation. We want to only go 180 degrees. So let's take the arrow. Let's keep the point, the origin in the middle, and let's rotate 180 degrees. That's about 45 degrees. Coming up to 90. That's a 90-degree rotation because the arrow is pointing to 90. So I have to keep going all the way until the arrow points at 180. So now we are ready to put our image where did the blue point move? It's not at 2, -4 anymore. It moved. So the arrow is pointing at 180. I like the graphs also because I can just see where it goes. I don't have to try to squeeze under the transparency. I can just remember that the point goes right here. Now, what are the coordinates of that? The new coordinates are, remember, x comes first, so it's x is -2, and y crosses the y at 4. So this is the new. The old, remember, was 2, -4. So what kind of connection do you see between the old and the new after 180-degree rotation? You should see that the numbers, you should see some kind of pattern. If you look, 2 turned into -2, -4 turned into 4 after rotating 180 degrees. So what happens is a 180-degree rotation makes the coordinates the opposite. The opposite of 2 is -2. The opposite of -4 is 4. So that's what a 180-degree rotation does to coordinates. Let's do example 2 to confirm this and see if it works with another example. So on this one, we're going again, a 180 degree rotation. So we're going 180 degrees. And we are going around about the origin. So the center is going to be the origin, 0, 0. And this says, without using your transparency, find the new point. So this up here, -3, 5, is what we're starting with. So we are starting with -3, 5. After the rotation, I'm going to make a prediction based on exercise 1. Because exercise 1, it made the things the opposites. The 180 degree rotation made opposite coordinates. I'm going to predict that after the rotation, -3 is going to go the opposite. So the opposite of -3 is 3. And the opposite of 5 is -5. So this is my prediction about where the new point is going to be after the rotation. Without using a transparency, I'm pretty confident. But let's try it with the transparency just to confirm that my prediction is correct and that my rule works. So here we go with our transparency. Remember, we need to label the point we're spinning around, the origin. We need to label the point, the figure that is getting spun, which is -3, 5. And we need an arrow pointing at 0 degrees. Oh, I forgot to label the degrees to help. Remember, 0 degrees is over here. 90 degrees is one L shape. 180 degrees is the straight line. 270 degrees is down here. And if we keep going in our circle, 0 degrees is also 360 degrees. There we go. We're caught up now. So now I have everything labeled with my arrow pointing at 0. And I'm going to rotate 180 degrees. That's 90. That is 180. And let's put our new point where we stopped after the rotation, which our new point is going to be right here. And what are those coordinates? Well, look, and x is 3. And when I go to the y, I get -5. My prediction was correct. So it is safe to say, and I'm going to add it to our notes right now, and you should add it to your notes right now, that 180 degree rotations around the origin, and remember the origin is 0, 0, so 180 degree rotations around 0, 0 equal opposite coordinates. 180 degree rotations make opposite coordinates. That's the first property we're going to talk about today. And you can see it in number 1, where 180 degrees changed to -4 into -2, 4, opposite coordinates. And you can see it in number 2, where -3, 5 turned into 3, -5, opposite coordinates. So that is just one trick you can do. If someone asks you coordinates after a 180 degree rotation, you can answer them without your transparency. Just make the coordinates opposite. Now remember, this only works for 180 degree rotations. So it's a special case. It's a special type of rotation. Let's explore some more with number 3 on page 57. So this one says, let rotation 0 be a rotation of 180 degrees. So we're going 180 degrees again. around the origin. So let me label the origin because that's what I'm going around. And remember, the origin is 0, 0. And let L be the line passing through -6, 6, parallel to the x-axis. So they did the line for us. I'm going to make the line a different color so it might be easier for you to see what they're asking me to do. They're asking us to rotate this line around the origin. So to help me with my rotation, again, I'm going to label the degrees. Oh, that's 0 degrees. I wrote that wrong. 0 degrees is over here. 90 degrees, 180 degrees, 270 degrees. So I need to rotate this line 180 degrees. So let's get the trusty transparency. Let's start my labeling. First, I need the origin, so I know where I'm spinning around. I need the line, the figure that I am rotating. And I need my arrow pointing at 0 degrees so that I can measure my rotation. So let's rotate 180 degrees. I'm rotating, I'm getting like 45 degrees right there, 90-degree rotation right there, 135-degree rotation about there, and then 180 degrees right there. So the arrow is pointing to 180, my rotation is done, and I can see where the line moved. So line L is up here. Line L prime, after the rotation, oh, might be a little bit hard for you to see on the camera there. Let me make it a little bit darker. This is L prime. So we rotated the L 180 degrees right here. Now the question is, what do you notice about L and L prime? What do you notice about L and L prime? What is the relationship? Think about it, come up with an idea. Pause the video if you have to. The relationship you should see is that L is parallel to L prime. These are parallel lines. If they go forever, they will never intersect. They are parallel. So just with number 3, what I notice is that when I rotate a line 180 degrees, I get parallel lines. Let's see if it works with another line. Number 4. It says, again, rotation be the rotation of 180 degrees around the origin. And it tells us we are using this line over here this time. So what happens when we take this line L and rotate it 180 degrees? What happens? So we need the origin, which is right here. Again, remember 0, 0. We have the figure we're rotating. We have line L. And we're going to label our degrees to help us measure our rotation. And we're going to copy things onto our transparency to help us. So here's the origin that I'm rotating around. Here is the line that is being rotated. And here is my arrow pointing at 0 degrees to help me measure my rotation. Now hopefully you're doing all of this with me. If I'm going too fast, you can pause the video and do it yourself. But it is very important you know how to use these skills. So let's start the rotation and see what happens when line L gets rotated. That's 90 degrees. We're not done yet because the arrow is pointing to 90. We need to move all the way until the arrow is pointing at 180. And that is the new line. That is the image of the line. So let's draw it right where it belongs. This right here is L prime. What do you notice about this relationship between L and L prime? Hopefully you noticed again that after a 180 degree rotation, L is parallel to L prime. So a 180 degree rotation made more parallel lines. Should we keep exploring? Why not? They give us more options. Let's see. Number 5 on page 58. We have a line that it's hard to see the line on my paper. Let me draw it for you. They give us this line. That's line L. Oh, hopefully you can see that. I might need a bigger marker, a bigger pen. And again, we are going 180 degrees around the origin. So there's the origin. Label your degrees to help you with the rotation. And this time I'd like you to do it yourself. Pause the video. Rotate that yourself and see if you get what I get after the video. After you pause and come back. Okay, if you pause the video and did the work, you should have done all this. Get your transparency on top. Label the line you are rotating. Label the point you are rotating around, the origin. And give yourself an arrow to help you measure the rotation. And you should have gone 180 degrees, just like that. So the new line is going to be right here. That's L prime. And again, L is parallel to L prime. We made parallel lines. Try number 6 on your own. Rotate that line around. Let me darken the line so you know exactly where it is so nobody has an excuse. That is L right there. And again, you're going around the origin. Okay, hopefully you paused the video, you did the work yourself. You did 0, you did 90, you did 180, you did 270. You used your transparency, but honestly, you probably didn't even have to. You could have guessed that the new line is going to be right here. And you'd be right if you said that L prime is right here. Because look, for number 5, the line was 2 spaces away, and L prime was 2 spaces away from the origin. 2 spaces away from the origin. And then the new line is parallel, also 2 units away from the origin. So for number 6, the original line is 4 units away from the origin. The new line, the image, is parallel on the opposite side, 4 units away from the origin. So you should be seeing a pattern right now. Let's see if the pattern continues for page 59, number 7. Number 7, they want you to rotate this line to see what you get. Now, for this time, I'm going to make a prediction before I get my transparency. I know I'm moving that line around the origin, and I know I'm going 180 degrees. Now, if everything else is the same, if all the other rules work, if the same pattern continues, then my prediction, the original line is one unit away from the origin. I predict that my new one is going to be on the opposite side, also one space away, to make parallel lines. This is my prediction. My green dotted line is the prediction. Let me set up my rotation with my degrees, and let me see if my prediction is true. So I'll get my transparency. You should get yours out to see if our prediction is true. So we need the line that is being rotated. We need the point, the center of rotation. And we need the arrow pointing at 0 to help us measure our rotation. So let's go around and see if 180 degrees lands on our predicted green dotted line. 90 degrees, we have to keep going. When the arrows point at 180 degrees, we see that yes, our prediction was absolutely correct. Our prediction was absolutely correct. So it looks like we can come up with another property of 180 degree rotations, that a 180 degree rotation makes parallel lines. But let's check. So far we've been using lines that go straight horizontally or straight vertically. Let's try number 8, a line that goes at somewhat of an angle, to see if this rotation also makes parallel lines. So we're still going around the origin, and it is still 180 degrees. Let's see what happens when the line has some slope to it. So we go 0 degrees, 90 degrees, 180 degrees, and 270 degrees to help us measure our rotation. And then we use the transparency. Maybe while we're setting this up, you want to make a prediction about whether the same rule will work. Will we get parallel lines after this rotation? Well, make a prediction. Think about it in your head. Maybe try to guess where the line's going to be. I did the origin. There's the line that's being rotated. And I need my arrow pointing at 0 to help me with my measurement. So let's rotate and see where our new line is going to be. I'm at 90. I need to go all the way to 180. The arrow is going, and the arrow is pointing at 180. And if you look at that, you see that, hey, guess what? They look awfully parallel. Let's draw the line. So I see it looks like the line goes at -3, 3. So I'm going to put a point at -3, 3. And I'm going to put another point at what looks like -4, -2. So I'm going to put a point right here. So if I connect those points, I'll see my new line. And if you look, that looks awfully like they are parallel. So we did the same thing. A 180 degree rotation made parallel lines. A 180 degree rotation made parallel lines. Let's see if it does the same thing without a graph. Let's do a little practice freehand. No graphing to help us here. You're like, uh-oh, Mr. Baylor, how do we do this without the graphing? Well, let's do it together. You can watch me, I'll show you. We're still doing 180 degrees. This time the center is 0, is O right there. So we need 180 degrees around O. Now we still need to do the labeling our degrees to help us. So I'm going just to do a straight line with O. And I'm going to say 0 degrees, 180 degrees. And then I'm going to do straight line down for 270 degrees. And I'm going to do a straight line up for 90 degrees. I still label my degrees to help me measure my rotation. Watch how it works. Again, just like before with the graphing, the center is O. The line is L, which I'm going to put in blue. And I'm going to do an arrow pointing at the 0. I just had to do the 0 myself because we're not on graph paper. On graph paper makes it easier because they already have the lines for you, but you can make the little, it kind of looks like a compass. You can make the compass yourself to show you the way. Now let's rotate the line 180 degrees. Not stopping at 90, going all the way to 180. Now this, because we cannot look at the coordinates underneath, we will have to kind of sneak under our graph paper. Under our transparency, not our graph paper, and figure out where the points are, but that looks pretty close to me. I connect the points to make my new line, the image of the rotation. And look at that. Looks like I made parallel lines. A 180 degree rotation made parallel lines. I'm going to add that to my note page. The first property we found was that 100 degree rotations make opposite coordinates. We also explored and discovered that 180 degree rotations of lines create parallel lines. So that's two things that we learned. If the rotation is 180 degrees, it's opposite coordinates. And if we do a line 180 degrees, they are parallel. So parallel lines are 180 degrees apart, and they have opposite coordinates. Couple skills that are important for you to remember, a couple properties that will help you with geometry and those kinds of fun things. So those are our two properties. Our notes are finished. You can read the lesson summary to help you. The first one says, you can just read those yourself. You can just look at your notes. I like my notes better, so I'm going to not read those right now. Your exit ticket, shuffle that to the 63 to the end. You're going to do that last. You have homework helper, an example that will help you with your homework today. So read through it before the problem set. Study it on your own and see if you can figure it out. But then you have, the problems, the homework helper is a couple pages. Then you have the problem set. What you're going to do is it gives you two figures, and it asks you a few times, does a 180 degree rotation map the original onto the image? So does BC after 180 degrees map onto B prime C prime? It means, can I rotate BC and make B prime C prime? And the answer is yes, it is possible. And the way I know is BC is parallel with B prime C prime. And remember, our property says a 180 degree rotation makes parallel lines. So if lines are parallel, a 180 degree rotation will map them onto each other, will move them to each other, will transform them to each other. So yes, it is possible because BC is parallel to B prime C prime, and after rotations make parallel lines. Number 2 and 3 are similar questions. You're just asking about different segments. And then number 4, you're going to connect the points they tell you to connect. So you're going to connect B and B prime, connect C and C prime, and connect A and A prime, and see what you notice when you make those connections. And then number 5 is asking you to determine, would one rotation move ABC to ABC prime? And if you say yes, what is the rotation? Tell me the center and tell me the degrees. So try your best on that. The answers to the problem set will be online on the linked on the Google Classroom. You can look at the answers yourself. Check your work. Do not copy the work. Make sure you understand, and if you do not understand, reach out to me or a friend for some help. There is a number 6 on the problem set. Number 6 is asking, is it possible to rotate ABC to make ABC prime? Is it possible that a 180-degree rotation will do this? Not just any rotation. Is it possible for a 180-degree rotation to move this here? Why or why not? So have some fun with the problem set. Make sure you try your best. Make sure you check your work and make sure you ask for help if you need it. After you're all done with the problem set and you're confident you understand the math, take a shot at the exit ticket. The exit ticket answers will not be online. I want you to do this yourself, and I want to see what kind of skills you have. But again, I am here for help, so even if you have questions about the exit ticket, just reach out to me and I will help you with the exit ticket. Have a good day, work hard, persevere, try your best, and I'll see you for the next lesson.